Where's my sound? All right, we got space. Let's do a time check first. The usual 13-second delay. All right, we got a few people on here for some level 3 calc. All right, guys. So how this session is going to work is I kind of sent a message earlier to actually put up some questions on the Padlet. So I've been actually getting some questions in the Padlet, and what I'm going to do is I'm going to answer those questions because these people have actually already asked these questions. If I have time after I finish these questions, I doubt I'm going to finish these questions because a couple of these questions are some excellent questions and they take a bit of time to explain. So if you guys want to know where the link to the Padlet is, it's actually in the description. So if you just go to the description, there is a Padlet there. You can just go to the Padlet, which should take you to this little page here. And you guys should be able to just add some questions on it if you want. Like I said, I'm working from the questions from the bottom up. So whoever posted first, I'm kind of answering those questions. The second thing is there is a link also to my OneNote, which is where I do all the write-ups. That can be actually up there. Yeah, sorry, Henry. I think that was the first question in algebra that actually came up, that question. So Sam K, no, it's not too late, mate. I've actually made recently I just put a playlist up called the Revision 2018 playlist. So if you go into that playlist, there's certain types of questions that I've actually seen that keep coming all the time in the exams. So I would recommend you to actually just have a look through that playlist. Henry, as for you, I know we were having a look at that question earlier, but I did have a play around with it, and I can actually explain where those two things came from. So anyway, we're going to get started, guys. I don't want to waste time because we've only got about an hour left, and at some point I got to go start gaming as well. Anyway, so first question today was this one here. Now, I can't remember, I actually can't remember where this question came from. I don't know if it's an achieved corridor question or a merit question, but it is a really good question to start off with, because there's a couple of things that you guys need to know and see so that you guys actually understand how this kind of breaks out into B. So the first thing you need to know is this. Whenever you're dealing with a quadratic, right, you're going to write that as ax squared plus bx plus c equals to 0. Now, one thing you need to know is that you can actually rewrite this whole equation. If I divide everything by a, I can write this as x squared plus bx over a plus c over a equals to 0. All right. I hope you guys saw how I actually got that. I just divided that whole equation by a. And of course, 0 divided by a, it's just going to be 0. Now, if I take a quadratic and if I factorize it, so I'm going to get two factors. All right. So let's say in this case, I get my first factor as minus alpha and my second factor as, second factor as x minus beta. So that means my two solutions for this quadratic is going to be alpha and beta. All right. Now just bear with me on this one, because trust me, this will come handy for you guys at some point. All right. So if this is the case, right, then what you can actually say is alpha plus beta is actually equal to negative b over a, while alpha multiplied by beta is actually equal to c over a. Now, if you're wondering how the hell did I actually get that b over a and c over a, what I would like you guys to have a look at is have a look at this little quadratic. If I expand the quadratic out, what I'm going to get is I'm going to get x times x, which is x squared, minus beta x, and then minus alpha x, and then plus alpha times beta. So now remember this quadratic equation that I have here. Now what we can actually do is we can actually start matching up things. C over a could be written as alpha b, and that's how I get this particular formula, that alpha times b. So the two solutions that you get, or the roots, if you multiply them, you actually get c over a. And the next thing that you should notice is I can do this. I'm going to get x squared, and I've got negative here as a common factor, negative x as a common factor, and I can write that as alpha plus beta. All right. Now, what then I can say is I could actually say that this part here, this entire part, is actually equal to this. So if I write that out, I'm going to get negative x multiplied by alpha plus beta equals b over a x. And because x is a common factor, because x is actually a common factor, what you can actually do is cancel out the two x's, and you've got negative alpha plus beta equals b over a. And then alpha plus beta equals negative b over a, because you're taking the negative to the other side and just dividing it, so you're going to get negative b over a. So basically, these two things are worth remembering, okay? Because it just makes things so much more easier when you're trying to work out these kinds of problems. So if you go and look at this question, so now we can actually start on this question. We've got 2x squared minus 3x minus 8 is equal to 0. So I can rearrange this as x squared minus 3 over 2x minus 8 over 2 equals 0 divided by 2 is just 0. So this can be simplified as x squared minus 1.5x minus 4 equals to 0. Okay. Now, the question is actually asking, find the equation where the roots are 4 times those of that. Okay, so what I then have is, I could actually write alpha. So if I look at that, or whatever the new equation is, if I say alpha plus beta, because alpha plus beta is equal to negative b over a, in this case it's going to be negative 1.5, then 4 times alpha plus beta is going to be negative 6. And if alpha times beta equals c over a, which in this case negative 4. What have I made a mistake with? Oh no, sorry, I forgot the negative there. That's it. That should have been, if this is negative 1.5x, because of this negative here, this should be plus 1.5 and plus 6. And if alpha beta is equal to negative 4, then 4 times that is going to be negative 64. So basically, we actually have this equation at this point, which is going to be x squared plus 6x minus 64 equals to 0. So the 6 ends up being here, the negative 64 ends up being here. Okay, and I believe that is the final answer. Now, if for any reason you guys kind of asking this other question of, well, how the hell did I actually come up with this? I'm going to show you guys one more little example. The red one, the one in the red box, is really useful to remember, that I'm going to do right now. Yeah, so that's really useful to actually remember. But if you really want to know how that equation came about, remember when you have a quadratic equation, x is equal to minus b plus or minus b squared minus 4ac over 2a. Remember that x is actually the 2 roots, okay, so the 2 solutions. So you can actually say alpha is equal to x plus, sorry, not x plus, minus b plus b squared minus 4ac over 2a, while beta is equal to negative b minus b squared minus 4ac over 2a. So if I actually do alpha plus beta, what I'm doing is this extremely long equation, I'm just keeping an eye on the time, guys, plus negative b minus b squared minus 4ac over 2a. Now, because I'm adding these 2 things, this and these 2 things cancel out each other because they're plus and minus. So what you're left over with is minus 2b divided by 2a, and that's where the minus b over a comes from. Okay, so that the alpha plus beta, the 2 roots. If we were to do alpha times beta, so alpha times beta would be like alpha was minus b plus b squared minus 4ac over 2a multiplied by minus b squared minus 4ac over 2a. Now, the denominator is going to be 4a squared, because 2a times 2a is 4a squared. As for the numerator, you need to treat it like a quadratic, okay? But what you should also notice is, because they're a difference of 2 squares, you don't have to worry about the middle term. So when you do negative b times negative b, you get b squared. Negative b times whatever this discriminant is, and then if you do the opposite of it, they actually cancel out each other. So that's why I'm not going to write the whole thing down. And then we've got square root of b squared minus 4ac times another square root of it, but it's a minus. So it's going to end up looking like this. But square root of b squared minus 4ac times square root of b squared minus 4ac is just going to be normally b squared minus 4ac. So the next step is expanding this negative out, and you're going to end up with b squared minus b squared plus 4ac, all that over 4a squared. Now the b squareds cancel out. You've got 4ac divided by 4a squared. A cancels out once, 4 cancels out, and you're left with c over a. You don't need to prove how the c over a came or the negative b over a came, but going back to this, whatever is in this little red box here, that's a really good hint to kind of keep in mind when you're doing these kind of root questions. I think I did show another way of how to do this question to one of my students earlier, and yeah, I mean, you could try and do it that way as well. But yeah, in all honesty, I think this is something that's just useful to actually try and remember. Okay, so that's my complex number question that was asked first. The second question that I'm going to be doing is in differentiation. Now, this particular question is I'm sure it's definitely a merit or an excellence question. I actually think of all the differentiation questions, this is one of the most, it's a straightforward one. It just kind of works out real nicely if you can draw the diagram and get the what do you call it, the dimensions right. But before I move on, I just want to go back to complex numbers. Is there any particular questions that you guys have? And I know there's some people asking for level 2 stuff. Guys, this is a level 3 tutorial helped us. The level 2 one will happen sometime later on. Just keep an eye on the notifications, all right? Okay, so I'm assuming that's pretty straightforward because I don't have any questions popping up. Keep an eye on that thing. Okay, so let's go to this differentiation question. So with the differentiation question, something like this, back in, I think when we first started doing differentiation rate of change questions, we were actually talking about, what do you call it? It's I think we called it the triple threat question back in the days. And the reason we called it a triple threat question was because this was a rate of change which involved 3 different elements. Okay, so I want you guys to have a read through this question real quick. I know it's a bit hard to see, but I'll try and blow it up a bit more. There you go, let's try that. So, the best thing is to, I always say with differentiation questions is, especially with rate of change questions, is write down what you have, what you're looking for, and then try and figure out what the question's actually asking. Sorry, yeah, you get what I'm trying to say. Just give me a second, let me explain it, right? So first off, you got a rectangular bar of soap, right? So basically a bar of soap, that's going to look something like this. Now it says it's twice as long as its width, so it doesn't matter which one you put as width or length, because as long as you get the right dimensions for them, then you'll be absolutely fine. So I'm going to put this as width. That means the length is twice as long as its width. So that's going to be 2W. And then its height is half its width. So it's going to be 0.5W. All right. So let's actually have a look at what's happening to this soap. This soap is being dissolved at a rate of 2 centimeter cube per minute. Now, this is the first clue that you have here. Let me actually do that again. This part right here. I'm just looking at the units. All right. Now, if you think about it, let me actually do the whole thing. Centimeter cube per minute. All right. So I'm just going to write that down here. Centimeter cube per minute. Now, if you think about it, centimeter cube is actually volume. Minute is time. So what you actually have here is you've got dV dt. That's what centimeter cubed per minute is, because that's volume, rate of change of volume with respect to time. So we can actually say dV dt equals to 2. So, but of course, I'm not going to really write that centimeter cube per minute. I'm just going to write that dV dt. Okay, the next question that they're asking is, next question, if you read the question, it says at what rate is the surface area of the soap decreasing? And it's also asking for rate, which means surface area with respect to time. So we got dSA of dt is what we are actually looking for. Okay, now they give this random information, not random information, quite useful information, because we need to know at what time do they want the surface area changing. So that's the last part here. So when the volume equals to 50, they want to know how fast is the surface area decreasing. So we're going to put that as volume equals to 50 centimeter cube. Okay. Now the next thing is I would usually say is, because this is what you're looking for, I would actually write that down first. I would write that down as DSA dt equals. So at the moment, let me just see what I've got here. I've got dv dt. All right, that's all I have right now. What I also know is that I know that volume of this cuboid is base times height times length, and I can rewrite it as volume is equal to 0.5 W multiplied by W multiplied by 2W, which equals to W cubed. All right. Now, generally speaking, you would have to come up with the equation for the box in terms of one variable. Okay, so notice how in this particular question, my one variable for the volume is actually W, which means I can actually differentiate this, and I can rewrite this as dv dw equals 3W squared. Okay, now the reason I call this a triple threat rate of change question is because on my, just need a different pen here. On the left hand side, I've got DSA and DT, but on the right hand side, I've got dv dt. So I need to get rid of the dv. But what I've done here is I've actually calculated dw dv. So that means I can flip it. I can rewrite this as dw and dv. All right, now the problem is, like if you think about it, dv kind of gets rid of itself. I've actually got dw in the numerator and dt in the denominator. I need to get rid of the dw. So what else am I looking for? Well, I also know that in the numerator, I need the surface area. So then I could actually go, can I actually write a formula for surface area for this cuboid? And of course I can, because the 6 sides, when I add up the 6 sides, that's going to be the surface area. So I can go surface area equals 2 times this one. I'm going to do this one first. So that's actually 0.5 W times W. So that's the red part there. And then I'm going to go plus 2 times, I'm going to do, let's see, different color. Jeez, come on, man. Should have a different color. All right, let's do 2 right there. So this one is going to be, the height is 0.5 W and the base is 2 W. So this is the black part right there. And then I go plus 2 times the top and bottom. So the top and bottom is that. So it's, you got W and 2W. So simplifying this, I have surface area is equal to, oh man, I hope I get this right. Hang on, let me just, I did do my work before this, just so that I don't actually end up doing something silly. I should get 7W squared. Let's see if that actually comes up. So we got W squared, that's going to be W squared. 2 times 1, that's going to be 2W squared. And then, no, I made a mistake somewhere here. 2W. Why did I get 7W squared earlier and I don't get 7 now? No, what am I doing? I know where I made my mistake. Sorry. That should have been a 2W, not 3W. See, I was glad I actually did my working before. Okay, so we got 2W squared times 2 is going to be 4W squared. So then your surface area is now equal to 7W squared, which means we can differentiate this. We get DSA of DW. Yeah, thanks guys, I picked it up. DSA of DW is equal to 14W. Okay, so now I can actually take the DSA DW and chuck it in here in my triple threat equation. So what happens now is the DW and the DW, they kind of disappear. And as you can see now, what I'm left over with is the things that I want, which is DSA DT, and it matches up to the opposite side. Let me just do one more thing. I just want to, whoa. So my DSAs match up. And I need another highlighter. Give me 1 second, guys. Let's go pink. And then my dt is going to be there. Okay, now that's the triple threat question. You set that triple threat question up, everything else kind of starts working out real nicely. Because watch what happens next thing. dvdt, we know it's 2. Yeah, got that right. dvdw, what was that? Well, we know that right here, we have dvdw as 3w squared. So we got to flip that upside down, which means it's going to be 1 over 3w squared multiplied by DSA dw, which is at the bottom here, which we calculated as 14w. So that's going to look something like this. So we can simplify this. 14 times 2 at the numerator is 28. 28w over 3w squared, and this simplifies to 28 over 3w. Now, have we actually answered the question? Well, we kind of haven't. All we have given is we've given the formula for DSA dt, but we haven't actually found out what is the DSA dt when the volume is 50. So that means what we got to do is we got to actually find out what W is when the volume was 50. Remember, we wrote the equation earlier that volume is equal to W cubed. So then we can say 50 is equal to W cubed. And so W would end up being the third root of 50, which is, I haven't actually done it. This is just a movie. So we got 50 to the power of 1/3. So that means the W is actually equal to 3.68. So we need to substitute for DSA dt. Now we know that DSA dt is equal to 28 times 3W, which can be written as 28 times 3 times 3.68, which equals to, what am I doing? 3.68 times 3 equals that, and then 28 divided by answer. So we should be getting 2.533. Now surface area's unit is centimeter squared. The times unit, I think, what did we do? Was it a minute? Yep, that was a minute. So we're going to put that as 2.533 centimeters squared per minute. Okay, guys, if you have any kind of questions, feel free to ask away. But the triple threat question, it's just one of the names that one of my ex-calculus students gave it. It is a nice question when it generally does tend to work out real nicely. But yeah, you will have 3 elements that you need to actually find out. Later on, if I have time, I will be doing another one of these triple, well, I don't think it's a triple threat question. Let me just have a quick look. What was it? No, it is another triple threat question that pops up. Now, usually the when I say triple threat, I'm talking about this thing here. You've actually got 3 elements. W cubed, if you have a look at Sanan, Serioza, if you have a look at my working right about here, no, guys, yeah, you're right. Volume of a cube is W cubed, but in this particular case, it is not a cube, because if you think about it, the height is not the same as the width, which is not the same as the length. All right, so you can't just go, this is just a cube, because it clearly is not a cube. The volume ends up being W cubed, which is just a misdirect. Don't assume that it's a cube. We know definitely it's not a cube. Okay, so as I was saying, with the triple threat questions, it usually ends up being excellence. I don't think this question is a merit. And usually if you get a triple threat question, you can, most of the time you end up getting, if you do most of it correctly, you should get 7 points. But if you get everything correct, you should be getting like a very straightforward 8 points in it. Okay, a couple of the things that I would also ask you guys to remember is just the units, all right? Because if you have a look at this equation, I don't think I have room to kind of work around it. I'm going to take this equation here, all right? And if you just write the units for it, let me see if I can squeeze some space here. Okay, so dSA dt was centimeter squared per minute equals, now dV was centimeter cubed per minute multiplied by width was just centimeter over volume is centimeter cubed times surface area is centimeter squared divided by width is centimeter. So this is another way of double checking that you've actually done the right thing. And then you can see that centimeter squared is in the numerator and the minute time is actually in the denominator. Sam, it's not really a particular type of equations that you need to memorize, mate. It is more like it's just kind of hard because you kind of start doing the questions and then you realize that, oh, this is something that we actually need to remember. The one I did in complex numbers is quite a useful one, and of course the exponential equations, differential equations are very, very useful. All right, guys, I'm going to move on to the next question here. This was an integration question, which, yeah, actually, Sam, here we go. This is a question that is worth remembering, this particular formula. Okay, guys, so where is not working? Okay, so this is integration. I would be assuming that this would be an excellence question because honestly, I don't know where this question came from, but it's up there somewhere. So what we're going to do is let's just break this down. First off, we got intensity of light, so that's going to be L. It changes X meters beneath the surface of the ocean, and it says that it's proportional to the light intensity itself. I hope that highlighter is going to come through, but whenever you see that, you've got your differential equation straight away. Is it going to come up? Let's see. Yeah, it does come up. Sweet. So because it's proportional, we can actually say the change of light given distance is some constant of L itself. All right. So Sam, this is where you'd remember this particular part. Okay. Because in the exams, what I've seen people do is they can directly go from this formula into this formula here. I think it's KT or something like that, but yeah, but I guess in this one you can actually put it as X instead of T. All right, I have seen people do this, and it really depends on the day, like, because in some places I've seen that you have to differentiate, and in some exams I've seen that where you can just jump straight from there to there. But anyway, I'm going to show you guys how to get to the equation on the right hand side. So you got a differential equation. That means bring all the capital letters to one side and take the dx to the other side. So you're going to end up with dl over L equals k dx. And you want to integrate both of these sides. Now 1 over L, when you integrate it, you're going to get ln of L equals, and when you integrate k, you're going to get, with respect to x, you're going to get kx plus c. All right. So once you have this, then the next step is taking e's, just put, well, you're taking exponential of it. So then L is equal to e to the power of kx plus c. Remember that c is a constant, so you can actually bring it to the front like this. You can write e to the power of c times e to the power of kx. The reason I've split that is because when you have index questions, if you add the two powers, it's also writing it as with the same basis being multiplied with the powers. So that's all I've done here. Now e to the power of c is the initial constant, so I'm going to just say it's going to be L of 0 ekx. Okay, so basically, yes, these 5 extra lines, it's worth kind of writing that down because yeah, I would actually always write it down. I wouldn't actually jump from here to here. That's just a bit too risky. So anyway, what do we know about here? I mean, that's just the equation itself I've come up with. Now the second, the actual question itself, it says the intensity of the light is half the amount for a diver at a depth of 6 meters. Okay, so basically that means x is equal to 6 and L is equal to, the light intensity is only 0.5. Sam, I'll actually go through some of the papers again and I'll try to remember, man, because off the top of my head, it's pretty hard to try and remember what kind of things you need to memorize, because sometimes I would say these are things you need to memorize, but it might not be equations at all. It might just be like methods that I'm using. Anyway, going to this, we still need to know what, I guess the question is, what happens when x is at 0? Now think about this. You're dealing with light. It says the intensity of the light is going to be half the amount at a depth of 6 meters. That means when the depth is 0, the intensity of the light should be 1, because it's going to be, that's the full light right there. So our equation is going to look like this: L equals 1 EKX. But I'm not going to really write 1 every single time in this equation. So I'm going to leave my equation as L equals to e to the power of kx. So because I know that x is equal to 6 and L is equal to 0.5, I can now substitute it into the equation. So 0.5 equals e to the power of k times 6. So I've got 0.5 equals e to the power of 6k. Now, if I take logs on both sides, I'm going to get ln of 0.5 equals ln of e to the power of 6k. But ln of e is just doing the opposite, so it just kind of disappears, and you got 6k equals ln of 0.5, and then k is equal to ln of 0.5 divided by 6, which means k is equal to, I did this earlier, so negative 0.1155. Now, we've figured out what the k is, so we've actually got our equation for the light's luminosity. It is e to the power of negative 0.1155x. Now, the question, actually, I didn't even read the full question because I just kind of started working on it. The artificial light is needed, so I'm reading from here, when the intensity falls below 10%. Okay, so, and you're asked to find out at what depth a diver can dive without artificial light. So we're trying to figure out at what point is the light's luminosity, am I saying that right? Light intensity is going to be 0.1. All right, and x being the distance itself, the depth of the water. So we're going to put 0.1 equals e to the power of negative 0.1155x. At this point, I'm going to take ln of both sides, so I'm going to get ln of 0.1 equals ln of e negative 0.1155x. But of course, ln of e just disappears, and I'm left with negative 0.1155x. And so x is equal to ln of 0.1 divided by negative 0.1155. Now, this part, I didn't actually do it. I hope I got it right, but let's see. Ln of 0.1 divided by negative 0.1155. So that's actually telling me that x is equal to 19.94 meters. So guys, that is, I would probably say that's an excellent question right there as well. This part right here, I'm going to say to you guys, as Sam was mentioning, this is a standard kind of equation that is definitely worth remembering. Okay, that part, and also the actual, you know, all of this part here, because all of differential equations follows that whatever that I've highlighted in the yellow there. Just good things to remember. Okay, now I've done an integration, I've done a differentiation, and I've done a complex numbers. So let's go back to complex numbers. Let me just pick up the question, guys. Give me a second. Where was it? In complex numbers, and I know I saw this question that popped up earlier, but I'm not gonna do that yet. Oh, actually, no, I can't do that. That's a good question, but I haven't seen it come as often. But anyway, we will do this question because it won't take that long. Of course, I can't expand post. Great. Sorry, guys. Oh, that's decided to shut down on me today. One second, folks. Let me just sort this out. Okay, so this was the question here. Find the locus of the point representing Z. Oh, I should have actually done this. It is a good question. So if you ever get a question like this, right? And for those of you that can't see this, this is actually 2Z plus I divided by Z minus 2. So this question here, it's just a painful question, all right? It's doable, but it just takes a bloody long time, and you have to be really, really concentrating quite a bit to actually make sure you get it. So it's asking you for the locus of the point representing Z if it's purely imaginary. Okay, so what we're going to do is our first step is this. Whenever you're asked any of these locus questions, a good idea to remember is that Z equals X plus IY. So I'm going to substitute Z as X plus IY. So I'm going to end up with 2X plus IY plus I divided by Z is equal to X plus IY minus 2. Okay, so all I've done is I've just gotten rid of the Z. The next part, what I'm going to do is I need to I got to multiply it by the conjugate of the base. So I'm going to rewrite this as 2x. I'm going to expand the brackets plus 2iy plus I divided by x minus 2 plus iy. Now the reason I did this is because I want to multiply by its conjugate. So it's going to be x minus 2 minus iy. And then on the numerator, I've also got to multiply by it, which is x minus 2 minus iy. Okay. So what we then have is in the denominator, we've got difference of two squares. Okay. So that's kind of nice and simple, because then you're going to get x minus 2 squared plus, no, minus I squared y squared. All right. I don't need to worry about the middle term. As for the numerator, I've got this ugly as expanding that I need to do. And this is what I mean by it is just an ugly question. Okay, but it does work. So you got to go 2x times x, which is 2x squared, and then you've got 2x times minus 2, which is negative 4x, and then 2x times minus iy, which is minus 2x iy. Okay, get rid of that. Next, I've got these two multiplying, which I've got plus 2x iy, and I've got minus 4iy, and then I've got, don't mess it up, JNDK, you got minus 2i squared y squared. So now that get rid of those three, then I've got the last three to do, which is I times x, which is xi, negative 2i, and negative I squared y squared. Okay, like I said to you guys, this was an ugly question. I wasn't lying about it. So the next part is to try and actually simplify this. Now, thank God some of these things actually get rid of each other, because I got 2x iy gets rid of from the other one. And then I've also got, what else do I have? What else do I have? 4iy doesn't explain. No, that doesn't go. Let me just see. I've got negative 2i squared here, which I'm going to replace with, no, I'm just going to write the whole thing again. Yeah, I'll do the whole thing again without the x I squared. So I've got 2x squared minus 4x minus 4iy. Now minus 2i squared becomes plus 2y squared plus xi minus 2i minus I squared becomes, I'm worried that I've actually done something wrong here. Okay, the last one. Sorry, guys. That should have been just a y, not a y squared. Because that minus I squared will become plus I. Sorry, plus y. Does that look right? I should have 7 terms altogether. Yes, and I can't simplify anything further. In the denominator, I'm going to get x minus 2 squared. Minus I squared becomes plus, so it becomes plus y squared. Okay, now this, you're still wondering what the hell is just happening here, right? Because you got this long ass equation, and it's almost like there's no end in sight. But trust me, there is an end in sight. Because if you go to the question, it says this is purely imaginary. All right, this is really important, this part, purely imaginary. If something is purely imaginary, then the real parts is equal to 0. So what I'm going to do is I'm going to go and find out all my real parts. That means they all have to add up to 0. So that's real, imaginary, real. The next one is imaginary, imaginary, real. So basically, those 4 things that I've highlighted in pink right now, they're all real. So what I can actually do is I can, if you really want to do this extra step, you could rewrite this as 2x squared minus 4x plus 2y squared plus y divided by x minus 2 squared plus y squared plus I, and I could be the common factor, which means you get negative 4y plus x minus 2 divided by x minus 2 squared plus y squared. Sam, yeah, just give me a second, man. I'll finish this question and I'll check out the playlist, all right? So because it says the real part is equal, because it's purely imaginary, that means this entire thing must equal to 0. Okay, so then we can actually say 2x squared minus 4x plus 2y squared plus y equals to 0. Now remember, the question's actually asking you for the locus of the point, and you look at this equation, what do you actually notice is what I'm going to ask. Now, I'll be honest, when I looked at this first, I just went, what the hell is this equation? Because believe it or not, I mean, like sometimes you get an equation like this, you know, like you might get like x plus y equals minus 3 equals to 0. Now, you know that if you rearrange this, you're going to get y is equal to negative x plus 3. So the locus is a straight point. All right. But when you see something like this, and this is another really good hint to kind of keep in mind. Sometimes this question, they extend it by asking, actually, no, I'm going to show you what this shape really is. I'm just going to show it to you guys. Give me a second. What you can do is go into the graphics calculator. Whoa. Have I made a mistake here? Yes, I have. Give me a second. Sorry about that. Go into the graphics calculator. When you go into the graphics calculator, go into menu, and then this is, some of you might never use this, but it's still a really good tool to use. Go into conics. And if you click on conics, it'll say select equation. Now look at the equation that we actually have. We have 2x squared minus 4x and y squared, blah, blah, blah. Just look for the equation that actually looks like the format that we have actually written there. Oh, there you go, right there. See how it says ax squared plus ay squared plus bx plus ui plus blah, 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 whatever. Just click enter. And right now, all you got to do is match those values that you have on your, in here with the calculator. So the a value, notice the a value for x squared and y squared is the same. So it's going to be 2. The value for bx is minus 4. The value for cy, c is going to be 1. The value for d, there's actually no value for d. Okay. Now, if you click on draw, wait, have I made the mistake there somewhere? Originally, I got a different answer. What did I get? Did I copy this wrong somewhere? I should have got plus 4x or minus 4x. Not minus 4x. Yeah, that's right. Sorry. I got it in my original one. So yeah, click on draw, and what you have is a circle. So if you want further details about this this particular circle, what you can do is click on Gsolve, and it actually tells you where the center of the circle is. So the center for the circle is at 1, -0.25. So I'm just going to write that down here. center is 1, -0.25. And if you want to know what the radius is, click on GSolve and click on radius. Radius is equal to 1.03. So what you need to say is it is a circle with center at 1, -0.25. Wow, that's killer, man. And radius of 1.03. Now, for those of you guys, if you want to know a little bit more, this is how you can do it the algebraic way. You've got 2x squared minus 4x plus 2y squared plus y is equal to 0. So what you could do is divide everything by 2. The reason I do that is because I want to complete the square. Because if I complete the square, I'll get the circle's equation. So divide everything by 2. So I'm going to get x squared minus 2x plus y squared plus 0.5y equals to 0. Now, if I want to complete the square, this would become x minus 1 squared. -1 squared is +1, so I'm going to put 1 in the end here. Then I've got y plus half of 0.5 is 0.25, so that's squared, plus 0.25 squared here. So if you look at it, I believe I've just shown you guys where my center is. See? If you have x equals to 1. Zonax, no, you don't have to describe the circle, but I'm just giving you guys a bit of a tip on how to find the center and radius, because this question, you kind of stopped at, you just have to describe it's a circle. But sometimes I've actually seen people, seen questions come up where they ask you describe where the center and the radius is as well. Okay, so it is a good little trick to actually have. As for the y coordinate of the center is right there, and then your radius, which is 1.03, is this right here. But remember that it's actually radius squared. So if I go 1 plus 0.25 squared, I get this. And if I square root, then I actually get the radius, which is 1.03. Okay. All right, guys, I've got, what have we got? We've got 10 minutes. I'm going to try and do this next question on differentiation, which, should I do it now or am I going to do it later? Because that is a bit of a long question. I might actually come back to that one. Maybe tomorrow I'll do it in a tutorial, and I'll actually record that later because I've only got 10 minutes. So I'm going to try and do this integration question here, guys. I do apologize if you can't see that. I will try and write what it's actually asking us to do. It says, show that the area between the curves I'm going to shorten this one, and I'll exactly 6√3. This is a really good question, and I think it can be done. And the two curves are y equals sec squared x and y equals 8 cos x. Okay, so basically what's happening with this question is you've got to find the area between the curves. All right. Now the diagram is actually given to you guys, which is actually nice of them, but the points is not given to you. I'm talking about this point here, because if you look at it, right now your diagram actually looks like this. What do we got? We've got a cosine. So that's your cosine one, and then your sec one looks something like this. All right. So we're not actually given this point here, and the shaded region that we're looking for is that right there. So what I need to do is I need to figure out what that red point first is. All right, to figure out what the Zonax, yes, it'll be available later as a video. I think it does get uploaded, and I'll also add it to the level 3 playlist as well. Okay, so the first thing is you got to figure out what that red point is. To do that, I need to put both of these equations equal to each other. So you got 8 cos x equals sec squared x. Remember that sec squared is 1 over cos, so we can say 8 cos x is equal to 1 over cos squared x. And then cross multiply this, we're going to get 8 cos cube x equals 1, and cos cube x is equal to 1 over 8. Then cos x is equal to 1 over 8 to the power of a third. So we're going to get cos x is equal to a half. Now, guys, this particular question, if you go back to the question itself, notice how the area, it actually says exactly 6 root 3. So it's really important that even if you use a graphics calculator in this, you might actually not get the appropriate value. And I was talking to one of my students earlier today, and I was saying that basically if you see like root 3, root 2, and you're dealing with trig, you need to go and find the special triangles. If you want to know what I'm talking about, it is this right here. If you go to your formula sheet, I should have had that opened up, but sorry about it. Now in your formula sheet, where is it? Where is it? There we go. In page 4 of your formula sheet, you're actually going to find this special triangles. All right. That's going to come very useful in this question because I want to show you guys how this all links up. So you're actually trying to figure out what is x when for what value of x is cos x equal to 1/2. So if it's actually 1/2, if we look at the numbers on the right angle triangle, these are the two numbers that we're interested in. We're not really interested in this particular triangle. All right. So for cos, it's actually adjacent over hypotenuse, right? Now, so this would be adjacent, and then this is hypotenuse, which means we can directly see that x is equal to pi over 3. Okay, so I hope that it actually made sense how I got pi over 3 real quickly. So this value here is going to be pi over 3. We're not going to worry about the other value. The reason we're not going to worry about the other value is because we are only going to find between pi over 3 and 0. And then we can actually double the area. Okay, so let's start writing up the equation. So the equation is going to be like this. Remember that when you want to find the area between two curves, you go integral, you've got your two intervals, which is b and a, and then you got top minus bottom dx. So let's go back. We know what b and a is. B and a are these two values here, which is pi over 3 and 0. So I'm going to put that here. So it's pi over 3 and 0. Then I'm going to go back and have a look at which equation is on the top. So if I look at this graph here, it's the cos equation that's at the top, and the sec squared equation is at the bottom. Okay, so that means I write down the cos equation was 8 cos x minus sec squared x dx. There's my working. Yep. So, and also remember, we want to actually do 2 times that because we're only doing it from pi over 3 to 0. But it's symmetrical, and we can just find half of the area and just multiply it by 2. All right, that's always the easier way to do it. Okay, so at this point, I need to integrate. So I've got 2 times, now 8 cos x integrates to 8 sine x. Luckily, there's no number in front of x, so I don't have to divide this by anything else, so we just leave it as it is. Minus sec squared x integrates to tan x. And all of this is between pi over 3 and 0. Okay, So next thing is just substituting them. So we've got 2 times 8 sine of pi over 3. I'm actually going to put that here like this. Minus tan of pi over 3 minus, now I've got to do that whole 0 part, right? So I got 8 sine 0 minus tan of 0. Now here's the thing, sine of 0 is 0, tan of 0 is 0. That means I don't really have to worry about this part at all. Okay? So all I have is 2 times 8 sine pi over 3 minus tan of pi over 3. Remember the question. The question said prove that the area is actually 6 root 3. Okay, now if you use the graphics calculator for this, I'll show you guys what happens. When you use a graphics calculator with pi over 3, so if I go in my calculator, sine of pi divided by 3, I'm actually going to end up with 0.866. Now that's not going to help me prove that it's 6 root 3. So that is why I'm telling you guys that your special triangles is actually useful in this case. So let me bring that special triangle back. So I'm not really worrying about the bottom one. I've got 2 times 8 sine of pi over 3. So let's have a look. Pi over 3 is here. Sine is opposite over hypotenuse. So that means sine of pi over 3 is opposite, which is root 3, divided by hypotenuse, which is 2, minus tan of pi over 3. So tan, you're going to get opposite divided by adjacent. So tan of pi over 3 is going to be opposite, which is root 3, divided by adjacent, which is 1. So that's what that's going to look like. So we can simplify this. Now we got 8 and 2 cancels out each other. We've got 4 root 3 minus root 3, because root 3 divided by 1 is root 3. And then 4 root 3 minus root 3 is 3 root 3. And you got times 2 at the end there. So this is going to end up being 6 root 3, which is what we wanted. Okay, so even though you might be able to do this in the calculator, this particular question makes you use the special triangles. Okay, so, and the special triangles are given to you guys in your formula sheet anyway. So just get used to the idea that whenever you see root 3 or root 2, or something like root 3 over 2 as well, it's just a good idea to go back and just see whether you can actually use the special triangles there. Okay, now let me just see. I've got 2 questions on integration, 2 questions on complex numbers. I only did 1 question on differentiation, guys. For those of you guys, if you're coming into school tomorrow, I might actually continue with this, answering some of the level 3 questions in the morning. It won't be a live stream, so I'll probably just upload just a standard video. All right, but if you guys are there, just pop over to the maths comments and I'll just go through them. Okay, that's it from me for this session. Thank you for popping in and thank you for your questions. If you do have any other questions, as I said, just put it on the Padlet, and then when I get some time over the next couple of days, I'll just keep working through them whenever I get some time. Tomorrow, guys, depending on, I might actually just see if I can send a poll out or something, whether people want level 1, 2, or 3. Yeah, but it is nice to work with a small group of level 3 students. The chat room doesn't go as crazy. Okay, so thank you for coming, and hopefully you actually learned something today. See you guys.